Hi students, now we can go for another category of chi-square test. The first two category we learn using chi-square are goodness of fit. Goodness of fit means what is the observed frequency, and from that value we calculate the expected frequency. And expected frequency is added to the number of rows. But here the condition is different. Here also we calculate expected frequency, but it is not considered for calculation of degrees of freedom. Don't get it? Okay, let us move to the calculation, then it may be clear. Here the situation is somewhat similar into the first case we already explained. Here three girls, girl 1, girl 2, girl 3 and boy 1, boy 2, boy 3 are there in a course of semester of a duration of I think 189 days. We have to add it, then we can, it is easy to recognize is it correct or not. We can sum up the values, sum up these values. Okay, yeah, 189. A total duration of 189 days. Boy 1 associate with girl 1 G1 for 40 days and girl 2 for 100 days. And girl 3 for 49 days. Okay, then now we can think that there are two other boys compared to the first case, and these two boys again associate with these three girls in this fashion: 49 days with G1, 46 days with girl 2 and 94 days with girl 3. So somehow there may be an association between girl 3 and boy 2, maybe, yeah. Then boy 1 and girl 3, girl 2, there may be. And boy 3 with girl 1, yeah, there is a chance. But in order to assure whether this association between these boys and girls is significant or not, we have to set a null hypothesis that there is no difference in observed frequency and expected frequency. Here we know only the observed frequency. Then we have to calculate the what is called the expected frequency. Here, in order to calculate that, we have to take total of each row and column, and this is the row total. This is the row total. Row means this is the single line, a row total. Okay, in that way we have to calculate column total. This is column, and we have to calculate column total too. Yeah, it's for these values and get enter. Yeah, again 189, right. Okay, now we got 189 in row total and 189 in column total. Then what is the grand total? Yeah, 567. Is it right? Yeah, it's right. 567 is the grand total. This is row total, this is column total, and this is grand total. And now we have to find out expected frequencies. Here observed frequency can be typed here, and we have to calculate the expected frequency. In order to calculate expected frequency of this column means boy 1 with the girl 1. Actually, among the 567 days or among the 189 days, if it is divided equally by 3, it may be appear here. Okay, but here the calculation procedure is different. Here the formula to find out expected frequency is that row total into column total divided by grand total. 5, 6, 7. Yes, but there is an error because the value is expected here is added here, so we cannot use that mechanism, so we have to remove it and use another way to calculate. Okay, here I paste the values, then here also I copy and paste the values here. Now that's enough for us. Okay, now it's good. What's the change now? What's the change now? We add just give the value there, right? Now we can calculate this particular figure. Here the sum is total is, here we can add in this way 567. Here we can calculate row total into column total divided by grand total. What's the value? Here the expected value is 63. It may be same and these three areas, but there may be some defect here because of zeros here, right? In order to make this correction, I add 5, 6, 7 and try 4. Again try for this area. Yeah, again some correction regarding into from this area. Then I think it is needed to calculate for each area is equal to row total into column total divided by grand total. Here also row total into column total divided by grand total. Here also in that way, in that fashion, we have to calculate expected frequency for each of these 9 values. But fortunately, in this particular case, the expected frequency is same for all the cases. 189 into 189 divided by 567 provides 63 at all the areas. Okay, and I made a mistake here that I have to give one more space. I need one more space here, so I shifted it there and typed the matter here. 63, 63 and 63. Yeah, this is the expected frequency. This is observed frequency and this is expected frequency for each line. FO, FE, FO, FE, yeah, FO, then FE, then FO, then FE, yeah. This is the values and this is total, and here also we can type total. Now we have to pick all these values here. I can add in this way 400, 40, 100, 49, 49, 46, 94 in that way. Okay, 40, 100, you can read to help me. Please read loud. 49, 46, 94, 100, 43 and 46. These are the 9 numbers: 40, 100, 49, 49, 46, 94, 100, 43, 46. Then what are the expected frequency? 63. Yeah, 63 for all. Okay, now FO minus FE. Now we shift to calculation. The same procedure for chi-square correction. The same procedure can be applied here. How to calculate? Equal to FO minus, that is 40 minus 63 and minus 23. In that way we can calculate all these values. Then we have to make square of these terms. Right. In that way we can calculate square of all these values, and divided by FE. We need to divide this factor with expected frequency, that is 529 divided by 63, right? And this is the value, and we need to calculate the total, that is sigma, total of all these values. So here I can insert function sum, and the sum value can be taken from here to here, and then now the sum is 88.85. This is the chi-square value. Then the remaining step, exactly same in the previous video of checking with table at particular degrees of freedom. Then here what is the degrees of freedom? How to calculate degrees of freedom? How to calculate the degrees of freedom? It is exactly same as in the last case. C minus 1 into R minus 1. What is C and R? Number of rows and number of columns. And here there is a change in the process of calculation, that is we omit this expected frequency. In first case, that is in goodness of fit, we use that expected frequency row in the calculation of degrees of freedom, but here we not consider that column. Instead we select column row number 1, row number 2 and row number 3. That is R minus 1 means 3 minus 1. Then column minus 1. Here there is column minus 1. This is column number 1, column number 2 and column number 3. That means C is 3, R is 3. 3 minus 1, 2. 2 into 2 is the degrees of freedom. That means it is equal to 4. 4 is the degrees of freedom. Okay. Then we use this 4 as our degrees of freedom calculation. We select the table, and in the table we use chi-square value of degrees of freedom 4, and we compare this 88.86 with the value in the table with corresponding degrees of freedom 4, and if the chi-square value is more than this table value, there exists a difference. That is, we have to reject the null hypothesis. There is no difference between expected frequency and observed frequency. Such a hypothesis is made, null hypothesis is made, we have to reject it if it is greater than the table value. We can check it from here, from the chi-square table. I think somewhere else the chi-square table is there. and based on that chi-square value we can check whether it is, I think, no, not this. Yeah, this is the chi-square table for degrees of freedom 4. We can compare with 0.05 level, 0.01 level, 0.05 level. As the obtained t-value, obtained chi-square value 88.86, a huge number. So it is greater than at any level. See, at any level it is greater than the values. So we can say that, confidently say that, at 99.99% confidence we can say that the observed frequency and expected frequency are significantly differ, not the same. That means there exists an association between these boys with these girls, and this is the use of this particular test. Here we use categorical variables, boys and girls, to compare based on their frequency of contact. In different situations we can use average achiever, below average achiever, above average achiever, their socioeconomic status, poor socioeconomic status, high socioeconomic status, average economic status. We can create a table like this, and we can compare whether the achievement is associated with the socioeconomic status. And it is a method of converting the continuous data into categorical data. Or we can use marital status like single, married and divorced, with several categories like expenditure, poor expenditure or average expenditure, and above average expenditure, below average expenditure, average expenditure, and above average expenditure. In that way we can categorize. In that way we can compare different categories and independent categories and of different groups. To compare, we can use this method, and this method is known as test of independence, chi-square test of independence. Okay, thank you for watching.